Okay, so without further ado, let's start our new lecture. And today we're going to look into something more practical in terms of the day-to-day usage, and that is frameworks, middlewares, and validation. And a classic approach to start an introduction to frameworks for Node.js is to start with Express. We mentioned already a couple of times Express framework in our previous lectures, and today is the time that we are kind of wrapping up the whole idea of what the Express framework is, what frameworks in general are, some framework-specific details will be covered, as well as the famous middleware pattern that is used even outside Express framework. We'll look into building modules, find what's available in this Express framework and what it's not. And we'll also look into something that is called validation. Some of you might be familiar with validating requests that are coming from front end and the importance of that in terms of the security, in terms of the integrity of your features, etc., etc. So that's what the validation topic is all about. So Express. As already mentioned, Express is a framework. It's really fast, mainly thanks to it being so small. It's a minimalistic web framework. There are lots of things that you need to still do in terms of backend configuration, but it is unopinionated. Any project could use Express. It doesn't force any project structure. It just provides that HTTP request response functionality in a easy, a more modern way, so to say. And you start this working with this framework by just installing it using your favorite Node package manager into your project. And then while you read through the documentation, you realize that there's nothing much left for you to do apart from installing it. You just spin up the server. So you decide what configuration you would like your server to have. You specify a couple of endpoints, and by endpoints, I mean those requests that your server will kind of handle. You also maybe learn a bit more about middlewares and what they do. You root those middlewares. Optionally, you decide whether your server will be serving just raw data, as in JSON, for example, or you would like your server, Express server, to serve static files. Because as you might recall from the discussion for HTTP protocol and just the smallest way you can organize a server on the back end using Node.js, HTTP doesn't really care what you're sending back. It could be HTML files, it could be JSON, it could be XML with a few caveats, but still nothing in the code that you're going to be writing using HTTP built-in Node.js module will indicate whether you're using static file server or will it be a data server. With Express, there is a few configuration required to kind of specify. It might be the only place where the Express framework is opinionated. It is used mostly to send back JSON in the response. So all in all, middlewares as a design pattern that is present not only in Express but in I think in web development in general is a backbone of Express. It's the thing that gives all the different functionality, additional functionality on top of just routing your request to Express framework, and it could be anything. So I think that's the point where we need to kind of discuss what the middleware is. So Middleware Concept is nothing more than just a function. It executes your code, and as a name kind of implies, it stands somewhere in the middle of two things. And those two things are basically the incoming request, in terms of when your Express server realized that this endpoint or server itself received the request, and the actual code that does something with that request. So in a kind of more traditional way to kind of describe it would be the function that catches the request or realizes that there is a request, and the function that handles that request. It's as if you were handling a click event, and before the event object goes to your event handler, the function, the callback, middlewares, a bunch of functions do something with that object, but still try to pass it along so that your handler is actually doing something. That's the basic idea of middlewares, and you can stack them. These functions could be stackable and called one by one, sort of like a chaining of functions that most of the I don't know, OP aware people know about when you return this keyword. That allows us to perform consecutive and isolated actions on the request object without actually doing any business logic. So 4 things that Express middlewares do. The idea was taken from the general concept of divide and conquer, of executing something, some changes, transformation. So nothing specific to Express, actually. Another point to make is that all those streams that we discussed, readable and writable streams, the stream that stands in between readable stream and writable stream, which we called transform stream, is kind of like a middleware. So just remember, middlewares are not some specific things to any framework. It's just a design pattern. And one of the main concepts is that it could be stackable. So a bunch of middlewares can be called one by one to do some transformation of those request to response objects, anything in particular, any data. And they basically don't have any business logic. They are there to provide utility function. So going back to Express middlewares, those Express middlewares, they solve particular problems that every request would have, not just problems, but issues, kind of like utilities that need to be done to every request. So middlewares in Express, they tend to be kind of unofficially divided into several different types. Again, just remember, middlewares are just functions written in a specific manner, meaning that they have a predefined number of parameters, and they, at the end of their call, they do a certain thing to kind of hand the result to the next something, be it a middleware or something else. So it could be application level, so spanning for every request there is for our backend. They could be router level, so only a particular router section that handle subsequent requests would be handled by router level middleware. There are also error handling middlewares, a specific type of middlewares. They also have a different number of incoming parameters to provide the error handling functionality. There are also built-in middlewares and third-party. For example, a well-known middleware can be something like body-parser or something like that, or JSON parser, anything. This is how they look. So a typical middleware, you'll recognize the usage of middlewares in your Express code when you see the app.use. So in app.use, it seems to be expecting a function to be passed, and that function is actually a middleware. So as you can see, nothing particularly different, except for there is a certain number of parameters that should be passed into every middleware request response, and then the next function. Without this next function that is executed at the end of each middleware, there won't be that chaining happening. So this is sort of like when you do the OOP style programming, writing your JavaScript classes, you would call or return this keyword after each of the method calls, so that next time there will be an opportunity to execute another method. So that's a similar thing. So as you can see, we're attaching it to nothing. So the first parameter to the app.use function is the middleware itself. That means it's a application level middleware. It will be executed on every sneeze of your server. Then the second one is a specific root middleware. So that's a router level middleware. And this is how the error handling middleware looks like. So as I mentioned already, middlewares are just function with a specific set of parameters, one of which is next, which is necessary to be able to kind of chain them and not lose your request along the line of middlewares. And the second one is the first error object. So in case of an error, if we specify a middleware, something like this, in case of an error on our application or router level, there will be some logic inside of your Express framework that will look for this specific middleware to be kind of provided by users, so that it knows that errors are handled in middleware level, and it will try to execute that function. If it doesn't find any error handling middleware, so a function that has this specific set of structure and parameters, it will not kind of do the error handling, and your error would just be lost in general, I don't know, thrown into std out without you doing anything. So keep in mind that middlewares and their types can be different depending on the number of parameters you use. So as you can see, a typical middleware just contains a number of parameters, then some utility code, some kind of logging, or maybe some request response transformations. And then specifically, the last thing you do is to call next callback. Okay, back to Express. So a number of things are available to you when you have an Express server. Let me just quickly check if there are any questions. Okay, seems like no questions so far. Okay, cool. Back to Express, there are specific things that you can do in terms of your Express server. And the first thing you do, without kind of diving deeper into those middleware details, is to actually start the server or create a server object. And you do that by calling this middleware express function. And what you get back is an application as a second one. And then The only concern you have after that is handling specific requests, providing specific response to those specific requests, and dividing your application into several different layers so that you don't have all the requests handled in a single file, and after some time you end up having lots of requests. So nothing kind of hard to understand. It's just that the structure of your typical server will always start with this single file. It would be server.js or index.js. Don't really matters. It doesn't really matter how you call it. It's just this file that requires the express package. Then you call this express function. It returns you the application or your server. You specify that the server will listen for a specific port, and then the server will have a specific set of functions, and that's it. So a typical kind of application, how it looks like for JavaScript, it's to have everything execute top down. But actually your application, your server, is that object that gets returned from Express. And whenever you execute this file in particular, that's how you kind of launch your server. If it goes down, you just go back and execute it again, like node space and name of this file .js. That's how you start and stop servers. So the server itself and the logic behind the scenes with the HTTP response request handling, all those protocols, etc., will all already be there, given you in the app.thing object, and you just make it listen to a specific port. So again, to kind of reiterate, you launch a server by just executing the main root or like index file that your server will have. It will typically start with something like this, and it will just respond to a specific set of rules or routes with this number of routes that you specify, and then we'll listen for the server of 3000. Okay, so just to reiterate, Express creates an application, Express application, provides some building useful middlewares for you. It's already a working server. You just specify what you want it to listen to. One of the routes, one of the kind of like building middlewares that it has, but didn't a while ago, was express.json that kind of does something with your serialized request body. And that's a specific thing that you kind of see in every application that uses the Express. Right? So that's all available in the Express package itself. The application. What is an application? What is that object that gets returned from Express? Again, it's an object that handles all the HTTP related stuff, methods, calls, etc. It has a general app configuration. You use that application object to add middlewares, kind of like declarative way. You register and use some kind of template engine if you use your Express server as a static file server or dynamic file server. Routes. Every application has specific routes. It could be it could be method, it could be used. So going back to our example, as you can see, .get implies that get is a get something from this route. So whenever a request comes to your application to localhost 3000, it receives and handles your /root level kind of root handler. So it executes this function, and whenever you return here using res.json, will be shown as a response to your request. So as you can see, this one .get implies that there is a set of functions that mirror the HTTP protocol under the hood. So, but at the same time, it has the .use, which is also a app level method, and that's what we mean when we have this one as all the top level roots. .all handles or the .get with a star instead of root will handle all the requests for get. It has different properties. You can look into that if you are so interested in specific of the application object. The only thing that I want to mention is, the app.set is sometimes seen as a way of kind of setting global parameters for your application. There are some built-in or kind of like hard-coded and reserved parameters, but you can also use that to set your global level parameters that will be visible for everything, for every root, no matter where you are in your root tree. A typical way of doing that is kind of like specifying some kind of proxy servers, some typical headers that every request should have. Quite nice things. So, and the thing I mentioned, parameters, there is also a app.param. It looks almost like a typical root that you would have. It's just the thing that you use to specify what could be passed to your application. So if you were to kind of get all the employees and you wanted a specific employee with ID that is specified as a number or as a string with a name, for example, a typical way to do that is to specify a root that looks something like this with a special notation the colon ID, and Express will understand this notation and kind of pass any root or any request that has this kind of root, and will extract everything up to the employee / and interpret that as an ID of your user. Another way, or more like explicit way to handle that is to specify that whenever you see the root with a specific thing with this name ID, please extract that using the app.param. But that's rarely used as far as I can tell. The main way to kind of have a tree of getting a specific resource in your application, in your server, would be something like this, with colon and the name. By the way, this part is up to you. You could name it whatever you like. It's just a typical thing to have an ID or name or param here, so that Express kind of maps your name that you use here with the actual data that it receives during the request. This is a more extended example of what I just referred to. So if we have this employees / ID, somewhere in the request object, Express will map what is found here during the real request to the thing that you specified during your kind of like setup or configuration of your server. And as you can see, somewhere in the request.params, so recall this name looks a bit similar to this one, don't you think? So it will find the same name under the one that you specified here, and will map that kind of like value to the internal of the params, and you will get that param in your code. So whenever you want to do some logic with it, for example, save that or get the specific employee with a specific ID from the database, you expect kind of like a dynamically requested IDs, and you just, for example, go and get that specific user from the database and either return it or respond with 404, which specify that there's no such ID handled. So a very typical way of writing servers and for handling some kind of create, read, update, delete kind of applications. Whenever you post anything, so recall the previous lecture where we discussed HTTP and their kind of verbs or methods. One of the method was post. So, for example, whenever I post something to backend, I want to, for example, save new employee in the system. I issue a post request to this route. I don't specify any IDs because I expect the system to kind of generate one for me. Because if I were to specify IDs, I would kind of always be guessing which ID is not used and which I can use to issue my request. So using post, we are kind of creating a new entry and we're giving just the data so that that creation could be based upon some real data that we specify. That's how it looks. So either app level or root level, we specify the .post / employees, and we specify the body. The body will be available in the request body, but there's one small caveat, is that to kind of get the actual body from the string that is a typical request. So remember, request is strings, just a specifically formatted strings, but still, to get that data from that string, we need to parse the body specifically, or in general, parse the string. So parsing of the path Express handles for us. That's why we get the ID from the request path or request URL. But parsing of the body is not necessary in terms of Express is unopinionated. That means it should be open to kind of extension as a typical solid architecture. So open for extension, closed for modification, or vice versa. I don't actually remember that. But anyway, body parser is there to kind of get that data from the request body if it has one. If it doesn't do anything. So don't be afraid to use that as a default. And then we'll be able to find the body under request.body. Use that to kind of update our application and maybe send something back. For example, an actual ID that could be used to later retrieve our employee, newly created employee. So yeah, at some point, Express adopted the body parser under its own kind of like building a module system. So now it's available in the Express.json object. Okay, cookies. Next thing that is typically kind of handled is a cookie. So cookies are also sent as a there are a number of ways that we can send using HTTP protocol a typical cookie, but to kind of abstract away from the details and finding a specific header or specific value that you agree upon, you have a cookie parser that will parse your request again and kind of create a new entry in the request.cookies with that value of your cookie. So you might already get the idea of all the middlewares. They don't actually do anything with your request apart from some useful changes, some parsing of your body or parsing of your cookies. and adding new entries to requests or responses if it is a specific middleware that does that. Again, we already mentioned that there are params that we can use. So params, there is a request.params, will have all the parameters of your request. So if the request URL is employee/42, request param with this kind of setup, with this kind of URL in your application, will map this name to your value that the actual request sends to you. If you don't specify anything here, if you leave it like this with a star, that is interpreted as a kind of everything or all in a typical backend development. So it either will store everything that is after the slash as an array. So that means that you are going to have everything, literally everything, even the next slash something stored in there as a typical value. Or you lose that data if you have any errors here. So it is a usual thing to kind of like the standard way of doing that is to specify a concrete or explicit parameters so that Express knows what to do and creates that mapping. Okay, let me just quickly check that we have. Okay, we don't have any questions so far. Let's go back. So query. You might have seen that URLs consist not only of path parameters, those slash something things, but also of query parameters. A typical query would be a key value pair separated with equal sign, and in the URL it will be noted as a string value after the question mark. Express also does pass the query for you. It will kind of store everything under the query object. So if there is no query string, it is an empty object in the string params. If it has anything, it will be stored under the request.query and the parsed kind of key value pair in a typical object. That's a nice thing to have. So if it has the several parameters, so order equals descending, then maybe colon, I don't know, limit equals 10, those request query will be all added to the request.query object as order descending and limit colon 10. So response. Response is something that you kind of like send whenever you're done with the handling of your request. So Express app sends the HTTP request. It performs those kind of like events on data, on send that HTTP expects. So Express does that for you. It handles different types of kind of headers that could be added. So remember, we used to have in one of the previous lectures HTTP example where we specified the content type, and content type application / JSON is actually the one that is specified here under the hood. So response object comes with a number of methods that all could ingest some data you want to send back, and those methods will differ by creating a different type of content type, a different type of HTTP response, etc., etc. Going back to locals, locals are those parameters that I mentioned that you can specify kind of to have access to any kind of configurations in any place in your application. So it will contain response local variables, for example, or request local variables. They will, like, the caveat here is that by saying everywhere in your application, I mean that we mostly work in when we kind of respond to requests. That means we can use local variables in every request, no matter the depth of our application. And that is a typical place we will use any request response objects. You won't be using in request and response object in your business logic. So that means that those local variables, those scoped to request and response variables won't be available there. So you kind of end up using either middlewares to access those or set those, or the actual request response routing logic. Number of methods that are available in that response object that we kind of get with every middleware or with every controller. This one, response object, it has lots of different methods. We've seen the Json one. It sets the Json response as an application /JSON content type. But we're also seeing a raw data, so a default response with data. It could be buffer string arrays, objects. We tend to kind of end our response to specify that the connection could be closed. HTTP, TCP connection could be closed using that. So whenever I specify the arrays.end somewhere down the line, well, in the OSI model, when we go from the application layer down to the transport layer, network layer, etc., that connection could be closed when we issue the end. The render method, also one of the usual method you see if you use Express as a kind of static file server or dynamic file server to kind of like render the contents of the HTML. It passes to the actual string that will send back in the response so that your front-end application could actually see the results. So before that, before the discussion of routers, just a quick reminder that all we did before, we were doing that kind of one file server application, which is not really realistic when we talk about production scale applications. The Express framework creators were also aware of that scalability issue, so that they created a kind of nesting inside Express. And that nesting could be as deep as you want to be, and you nest at the kind of resource level. So just a quick reminder, resource is this part. So instead of actually specifying all the routes, get, post, update, delete, and stuff in this file, I will say that my router will handle all the employees, or my router will handle all the, I don't know, apples, or all the users. And then I will call that a router, employee router, user router, Apple router. And then at the router level, I will focus only on those specific routes, kind of have some organization in my application. Sort of like creating a number of folders and then doing your specific request handling there. So it isolates some routes. It creates additional layer. You can specify specific middlewares to be available that layer, to work in that layer. It will have its own parameters, it will have its own middlewares, all of that. So kind of like an instance of your application object. This is how you create that router level object. So a typical application with routers would be something like this, an application server that will be listening to port 3000. and then a specific router, so another object. And I need to nest my router object to my server object, and I do that using the app.use. So under the hood, it looks kind of like having a middleware respond to a specific route. And that's what all routers do. They kind of respond to specific routes and do the same, their own logic. So think of it as a logic division of your application, kind of like creating slices of routes. It has some options, as everything, I think, when we import a new package. You can specify merge params, so whether the request from every other router will be available for the parent route. Strict, it is kind of like how sensitive it is to the URLs. Case sensitive and kind of completion sensitive, so whether it responds to /users or /users/ something. So this is a typical setup of that router. So as you can see, I'm mapping it in parallel, and then I'm specifying it in parallel. So it won't be different from the application specific routes. Nothing too fancy here. As I already mentioned, if I want something to, so this router is under the / router slice or section. And if I do that, I will tell that, hey, every route under the / should have authentication, and it should load users. And all the router / API should also have the authentication. So that's kind of a nice way to group things, sort of like you do with your folders and your desktop. Params are not much different from the application level routing. So you'll have ID available with the same column way of specifying the name of your IDs. You have implicit or explicit specification of IDs, kind of like imperative way of doing that. Again, one of the cool things that routers have is that they have their own level of middlewares, completely isolated from any other routers. So if I need, for example, the /API that we mentioned just here, to have an additional level of authentication, or vice versa, if I want to expose my API to kind of have less authentication, make it public, I can do that on the middleware layer without specifying so many kind of like repeated functions. I can reuse the middlewares I already have or have a different one. So that's the idea behind express routers. So, and you also have at the router level the duplication avoidance kind of like way of creating your requests and response and your routes. And again, as a typical middleware, I mentioned that already, in the OOP you have the chaining capabilities with this keyword. It is the same with routers. So if you want to have route for this specific URL, and I don't really care whether it should be get this route or post to this route or put to this route, I will specify, hey, all of those requests should first go through this middleware, and the get ones should be handled like this, and then I can put another dot on post and specify that the post request of this URL should be handled in a different way without specifying it router.get, then slash employee's ID should be handled like this. So it allows us to avoid the duplication of root names. And less we have the kind of like roaming free strings here, the less typos we make, because as we know, JavaScript doesn't have those string validation thing. If you make a typo here for one of the roots, you'll be guessing what happens, what causes the error, if anything arises. I think we discussed it already. So that as a typical app level middleware, you also have the router level middlewares follow the same things. So calling next is a must at the end. So if I don't call next, it'll bypass the remaining root callbacks. Use is a way of specifying the call or the middlewares at the router level. Again, already discussed that. Yeah. So just kind of a reminder to everyone, middlewares are a key concept in Express. It is not unique to Express, but Express was a framework that heavily depended on middlewares. And just because of Express framework, this middleware pattern became so popular. It is now used, I think, in many places, and the concept is simple. It is a function, specifically written function, that could be chained with other similar functions. It doesn't do any business logic. It's just there to provide some transformation or utility function to your request and response, or anything that you pass there in your call chain. Okay, so just a quick pause. Have some questions. Okay, what's the difference between res.json and res.send? Okay, yeah, that was answered. Just kind of to reiterate, JSON, res.json is almost the same as .send. It's that using send, I need to provide additional information, additional headers for browsers, for the consumers of my API to kind of understand what I'm sending. And .json already does that for us. It specifies those headers, the content type headers. So it's just a kind of utility function. Does it leverage streams in any way to send large files? Let me just go back to those. As you can see here, sending response has lots of different ways to send response, if that makes sense. So one of the ways is send file. It is kind of the way to do that. I believe it does something under the hood with streams to kind of do that for us, so you don't actually worry about streaming and creating write, read streams, all that. Just one small thing is that request and response objects, they are special. So whenever you read something from requests, since it is actually uses something under the hood, kind of like a stream. Whenever you read from a stream, as you know, whenever you connect to the pipe with some water, if you kind of drain that pipe, it won't have any data left. Same with requests and response objects, requests in particular. If you read request object, it kind of like you consumed your read stream. There are no data left there. So it is sad that you cannot read the same request object twice, because you kind of already drained the pipe and it doesn't contain any data. So whenever you need to read twice your request object, you usually copy it entirely. Not the request, but your data somewhere in memory, maybe in some cache, in any way possible to kind of work with that request object more than you need to typically. It's an anti-pattern. It's not just kind of like it was done specifically for this kind of like request response one-way flow of data and divide and conquer approach, so that every request should be consumed once. Something is done with that request data, you then issue a response, and then you close the connection. That was like the assumption. That's how the HTTP works. It just allows you to do multiple things. Express, in being like an opinionated framework, it just forces that small thing on you, meaning that the request should be handled just once. You don't need to handle multiple things all at once. It might be confusing at the moment. Just bear with me. You won't be working with like that detailed stuff in your homework, or probably in your production experience also. Just keep in mind that somewhere under the hood there is at least one stream, and you either consume it or you send it back when you send big files. So hopefully I answered that question. I'm asking to understand whether it would be a good practice to use Express for running a service that works with large files that I don't want to keep in RAM memory. That you don't want to keep in RAM memory. It is basically okay. Let me answer this question in the following way. Express, as well as Node.js, is basically to answer API calls with some data. It was initially used to serve static and dynamic HTML files, but the main purpose is to provide this light speed way of handling your JSON data, posting it or getting it from the server. If you want to have large files somewhere, you usually use another server, for example, a typical static file servers like AWS S3 bucket, or maybe some Google Drive, anything like that, that is specifically built to hold large files. It has all the functionality to do that already. Application servers are not the place to hold any data that should be persistent. Any data that doesn't suit RAM memory, doesn't suit to be stored into a variable, is not a good data to be kind of like holding in any case and handling it using application. What you can do is actually, whenever you want to get that file, you can create an application request response kind of like endpoint that sends back a link to that file, so that you can use your browsers to download that. And that's a typical way to do that. For example, you're storing a big chunk of data, use that with Express, or maybe you're sending files somewhere and use your Express to generate a link and return that link to you. So that's kind of, so if large files are static, wouldn't they be handled by Nginx without going to backend? Yes, that was what I'm implying to. Is that application servers? No, okay, so you just need to kind of understand that this is a Node.js course. It's not a system design course. So I'm kind of like answering your questions, but you need to have a bigger scope, bigger understanding of how backend works before you dive into those specifics. So kind of to quickly answer that question, static file sending, and in general server-side servers on the backend, they have different types of servers. So they could be application servers, the ones that handle mostly JSON data like Node.js, and Node.js is perfect to be an application server. They could be web servers, like Nginx could be used as a web server. Web servers are those servers that are kind of dumb in terms of the data, but are smart enough to just return HTML files, either dynamic or static. Usually static. If you need some dynamic functionality, behind the Nginx, there would be an express in the static mode that will handle those kind of pre-filling of HTML and returning the end result HTML. That will be then returned by the Nginx. And then there are different kinds of storage servers. And one of the storage could be okay. There also have the static file storage, block storage. There are also database storage, so different kinds of storages. Typically, files that are not HTML, CSS, etc., that are considered like either file storages or block storage. And some JSON data is considered to be suitable for database storage. So there would be a server that has the database running on it. It will specifically do that. There won't be any Express on that server. There will be just a Postgres SQL running instance, or maybe some MongoDB running instance. And they will be specifically serving JSON data. And the one that I mentioned already, being AWS S3, is a typical example of object storage or file storage, as you would like. There, its responsibility to actually be able to store any kinds of file sizes, and Express servers in that setup, being an application server that doesn't really work with large files per se, they will be used to retrieve links to big files from S3 and return to the user. So it will be a lightweight application server that upon the request for the file, it will just go to the AWS S3, it will retrieve that link, and then its job would be done. The scope of actually downloading a file would be on the client side. So hopefully that does make sense. It is a bit deeper into the backend development. It's definitely outside of scope of what we're trying to do here, but just indicate in the chat if you kind of got the idea. Okay, I assume that you at least understand at this point that Express as a Node.js backend framework has specific kind of scope that it handles. Node.js, as you know, single-threaded, non-blocking, all of that. It's not suitable to handle databases. You can't use Node.js to be a database. You can't use Node.js to handle chunky mathematics, so computations. It just doesn't really good at doing that kind of thing. So it is good to organize some static files in terms of HTML and CSS, JavaScript, maybe some dynamically generated files, like dynamically generated HTML files. And it is perfect to have an API with some routes that will go to the database, retrieve some data from there, links from static file hosting, and return to the user. So Node.js is a perfect solution to have an API thing. Yeah. So as far as I can say, yeah, yes, thanks. We're dealing mostly with API types of service in this course. Yes, definitely. And Node.js in particular is really good to organize some API for your needs. Okay, but what a typical API needs, actually, apart from doing some business or handling some business logic under the hood, it needs to be able to correctly validate requests, whether to prevent some malicious intent, whether to simplify the business logic that we have behind the actual requests. And to do that, there is a concept called validation. So think of validation as what happens with your requests, no matter the HTTP, verb, post, delete, get, anything like that. So even before that, even before all your middlewares, the first kind of protection, the first kind of thing that will be executed is a validation. It comes with middleware, yes, in the middleware form, but it's not like specific to middlewares in any case. And its idea is to create a declarative schema of data for almost every request that you want to have in your API. So if I want to have a request that has some body, that has the username, password, access token in it, and those values should be strings, alphanumeric, min, max, etc., etc. Some of them are required, some of them are numbers, or could be numbers of strings. So these schemas then applied to specific data, specific objects that you send along your requests, and if they pass those requirements, request goes into your business logic. If they don't, the business logic is never revoked, no authentication, or etc., etc. So there are a couple of ways or places you specify your validation. And there are a number of solutions that are available for validation. This data is a bit old. As far as I can tell, among those three libraries, Joy, the second one, is the most popular at the moment because it could be used anywhere, so it's kind of agnostic in terms of the client or server usage. So Joy is being a popular one. It's the one that we see here. So we require Joy. We use that Joy object to create our schemas. And then we call joy.validate, providing the schema that we have and the data that we want to have validated. And if it does pass, it will be passed along. If it doesn't, we'll have an error. That's how it looks in kind of like middleware style. So we create schema, we create some kind of callback. That callback will get the schema from the memory, and then use that to validate the request that we have. So that is just a moment. Okay, that's how we're going to use that. So as you can see, our schema is one of the middlewares that you can do. So just judging by this notation, it should return upon execution some kind of a middleware notation with request, response, and next. And that's what we see here, request, response, and next. We just use additional wrap function to kind of like dynamically provide schema for validation to reuse that validate schema middleware. It will be just for everything that has body, and it will be just returning the 404 error, which is client types of errors that will specify that, hey, you're trying to use our API in a unpredictable way, or it'll just pass to the next middleware. And in our case, it will be controller already. So that's a typical way to write a schema for us. And schemas could be different. So depending on the router and the actual route, we'll be using the same function with a different schema object. And yeah, that's it. That's all we have for validation. This is how Postman will look like. So we're sending a post request to this route, and in the body we'll specify ID, name, age, and admin. And we assume we are doing this validation. So admin is required, ID is required, names and age are not required, and age should be numbers, name should be string with this range, minimum 3, maximum 30, and age should be either 18 or 99. So we're specifying, we see that the body of our request, it seems to have almost this like valid schema. However, age restriction doesn't pass because we have the age being a number integer, but the range is not the one that we're trying to have here. So, and JSON would actually respond with the error, and error response is just kind of like schema errors and some kind of atypical error notation. We're just trying to be smart about it and specify what happened here in a more readable way without passing any stack trace, because in the error, as you might know, there won't be just what happens, but where and all of that. We don't want that to be exposed to clients, because that could be used for forensics and for security violations. So we're getting the path and message, just that, and what we show here is the actual message. Okay, that was a lengthy lecture. Hopefully you got an idea how to work with Express. To kind of reiterate, we went through the installation, we went through how to set up your application server, how to break your application server into different routers, so how to organize your folders, sort of thing. But as you can see, we didn't go into any how to organize the actual project structure in terms of folders, where should you have your business logic and where should you have your controllers, etc., etc. That's what we mean when we talk about Express being unopinionated. Express only handles the things that we discussed here: requests, parameters, validation of those requests, using a middleware again. And middlewares in general are a key component to Express. So if you go to any interview, you'll most likely be asked, what is a middleware in a typical Express application? So make sure you kind of understand the idea and different types of applications here. So are there any good practices, templates on how to organize projects? Yes, there are. I will send a link to a I think the most extensive like guide that I could find, that to the point at least, and without any kind of like hard opinions and stuff, if you would like me to do that. But in any case, there are typical kind of approaches to organize Express applications. The most popular ones end up kind of forming a new types of frameworks, so frameworks on top of Express framework. So don't worry, I'll send that link to you. It's not that hard as you might think. The best way, in my opinion, when you start out with Express is to just have those basic stuff that you've seen during your presentation up and running with routers, with all that, and kind of go from there. Just keep in mind the divide and conquer approach and kind of single responsibility thing, all those type of solid practices, and you'll be fine. Any other questions regarding what we discussed? Okay, extra one. If we use TypeScript in which transpile anyway, is it okay to use ES6 plus syntax, import export to be exact? Actually, yes. By the way, at some point, Node.js has started support of ES6 import export module system by default, so it's not even Express specific. If you don't want to kind of handle those experimental flags, etc., that Node still has to work correctly with ES6 import exports, yeah, feel free to go with the TypeScript example. One other thing for the project that didn't use TypeScript was to do almost the same thing that we do in the front end. So basically have a typical Babel setup in Webpack to do all kinds of transpilation. But TypeScript is completely fine. Moreover, it's encouraged to try and do TypeScript. It's just when starting out with Express, it's easier to just go with typical CommonJS modules. And you'll still see lots of projects using that CommonJS approach. Okay, any other questions? Okay, if you don't have any other questions, thank you for attending today's lecture. Hopefully you now understand a bit more about Node.js, how server programming and backend engineering works. I'll see you in the next lecture where we discuss a bit in more detail in terms of how the production level applications work. Okay, so see you next time. Thank you.